All right. There we go. So let's start off with basics. Let's go to hydraulic principles. So, like I've said last semester, this is not something I'm going to be testing you on right away with these pressure and force areas, work over distance. But what you should know is what these are. All right. You should know that pressure is pounds per square inch, PSI, or pascals is newtons over meter squared. All right. That should stick out in your head because it means something. All right. Just how energy is in pounds foot. All right. So let's talk about the principles though. Pascal's principle is pressure in an enclosed volume is the same everywhere. All right. It's the same reason when we talk about our regulating valves, how I was saying in this position here and a position all the way over here would be the exact same pressure. All right. So we have 100 pounds going down on 2 square inches. That's going to equal to 50 PSI. And that 50 PSI is spread over the entire area, no matter where you take a pressure reading. So we have a plate with 100 square inches, and we have a car sitting on top of that plate. We would be able to lift it using this hydraulic leverage. Skip too quick. There we go. So if we go down 25 inches in a 2 square inch area with 100 pounds pressure, we would go up half an inch on the car end. All right. So we have our energy input and our work done in our outlet. Now, if we wanted to move this car more than just half an inch up, we would need to use check valves and a reservoir to keep adding additional fluid into the system. So every time we go down, we'd move the car up half an inch. We'd have to suck more in through the reservoir, and we would just keep going with that aspect. Right. So we have a couple of different things. We have our energy production. That's going to be our AN devices. All right, so our pumps, linear, rotary, telmotors, accumulators. We have our transmission distribution control. So any of our tubing, valves, pressure regulators, and our energy consumption, our BN devices, piston, rams, hydraulic motors, everything like that. So we have what's producing the energy, what's moving that energy, or transporting it, and then we have our energy consumption. So instead of having just a regular old piston going up and down, we can utilize a positive displacement pump and a check valve. That will be our A end. We have a pressure regulating valve. And then our B end is going to be the vehicle. So we can use hydraulics to start a diesel engine. All we need to do is just have a start motor, start spinning the engine. That's all we need to do. All right. Sometimes it's done with air. Sometimes it's done with hydraulics. On vehicles, it's used an electric start motor. All right. But you can use hydraulics. And all what it is just you have 3 accumulators that are all pressurized. All right. So they're given around 3,000 PSI. And they're going to go through a motor And that motor is going to spin, and it's just going to deliver all of that hydraulic oil into a reservoir. So the same thing as if we were using air pressure to start it. We're just going to be using hydraulics. All right, and that would start the engine. And of course, we would need something to pump back up. So moving on from there and all those simple principles, let's go into hydraulic system components as far as what we really have a good example on is on the TSES, which is the steering gear system, for how exposed it is and how much you guys can really see what's moving. All right. So on our A end, we have our telemotor. So this would be the helm. And our B end is going to be this ram. All right. So if we move the helm in one direction, it slides these pistons. It's going to put pressure and it's going to move the fluid inside. And it's moving our ram on the other side. All right. When one side is sucking out the fluid, the other side is pushing that fluid in. All right. You can't have two sides that are going to be pushing fluid in. So instead of having just the simple system like this, which would mean that we would have to have very long hydraulic pipes and really strong people on the helm, we're going to be utilizing some sort of pump system with electronics. All right. So we're going to use a rotary B-end device. Oh, no, we're not using it. I'm sorry. Thought this was going to be going into the pumps. So there are rotary types instead of what we have with our rams. And what you would have with that is you would have a pump down here that would be constantly flowing. And that constant flow is going to change in which direction it's going via the shuttle valve. So it's going to be constantly going through this pump, but which pipe it takes is due to which position this valve is going to be in. All right. So in this position, one side is going to have pressure and the other side is going to be removing the hydraulic fluid. All right. So that deep orange is going to be adding fluid. All right. So as you can see, we're pressurizing this side and we're pushing fluid into these areas. Simultaneously, we're removing fluid from where I'm drawing the X's. All right. And that can change just by going to this alignment in the shuttle valve. All right. And that changes the position of a rudder. All right. And of course, if you just leave it as is, like I said, this pump is just going to be constantly circulating. So if it's in this U-joint position, we have locked off any fluid movement coming from this B-end device. And so this rudder is going to be locked in this position that it is right now, even though the pump down here is spinning. All right. Any questions so far? All right. So let's talk about the axial piston variable stroke Waterbury pump. All right. It's the mother of all AN devices. It pretty much is just, it's everything you would want in an AN device for hydraulics. All right. It rotates at a constant speed. It rotates in one direction. It can pump in either direction, not done by a shuttle valve, but just by, as we talked about, the tilt plate. And it can do variable flow rates. And all of this is done at that constant speed. So we're not going to be changing the speed of the pump to get a different flow rate. Right? We're not going to slow down the pump and then speed it back up to pump in a different direction. It's just going to be constantly spinning in one direction, and we're going to get all of these things out of it. So we have the barrel, and in the barrel we have cylinders. All right. And inside the cylinders we have pistons. The pistons are going to be riding on what is called a socket ring. These balls right here are quite literally just metal balls that a stick is sticking onto. The piston sticks onto it, and it's going to be, that's what's going to be riding on the socket ring. All right. Now, this is going to be spinning this whole assembly together. The barrel, the socket ring, and the pistons. So they're rotating in one mass. But as it rotates, in this position, it's not going to be pumping any fluid because these pistons are not moving. So in order to differentiate inlet fluid and outlet fluid, we're going to use this port plate. So it's going to line up with 2 of the 5 at a time. All right, and this is how we're going to be separating our fluids from the inlet and the outlet fluids. Okay. And as you can see, the one on the way bottom is going to be blocked. Those are tilt box. So the barrel, pistons, and socket rings are rotating. The port plates and the tilt box are stationary. So this gray piece right here is stationary, and this gray piece is stationary. All right, they're not going to be in any rotation. So when this tilt box or tilt plate is in its neutral position, all right, in its 0 position, almost, you're going to have no pumping because this piston riding in the cylinder is not moving. So it's riding vertically up and down in a straight line. There's no movement laterally, so there's nothing that's going to be pumped. Okay? So as soon as you tilt this tilt plate or tilt blocks, you now are going to have movement laterally of that piston in that cylinder. All right? So if this dotted line was in the neutral position, where it was riding that and it was not moving any fluid, now we're going to have this piston is going to ride this tilt box because it's going to be moving, and as it rotates, it's going to want to ride this. And now we're going to actually have a stroke. All right, So from here to here is the stroke, and that volume is going to be pushed out of fluid. All right. Now, when we go on to the other side, we go on to the suction side, same thing again. This to this position is now sucking in fluid on the other side. As it comes back up, it's going to be rotating. As it rotates laterally, the piston's going to move backwards from what it was, and it's going to be sucking in fluid. If you move this tilt plate farther back and you give an increase in angle, that's how we get more fluid flow. All right. So instead of having a small stroke in which you had from here to here, you now have double that amount. Does that make sense to everyone? Yeah. All right. So the last but not least, to go backwards and to reverse your flow. Remember, we're not going to reverse the speed. We're not going to reverse anything. But what we are going to do is we're going to change our tilt box's direction. We're going to have a forward tilt. So instead of the top being the point where it's sucking in, we are now discharging at that point. So on the near side, we're going to be sucking in all that fluid. And on the far side of what this barrel is we're going to be pushing out that fluid. It's the opposite of what we were just doing. So we're going to have all this fluid collected, and it's going to have one outlet and one inlet. All right. What we have here is just basically a small drawing of what it would actually look like in a schematic. All right. So if we have a forward tilt right now, and this is going to be matching up with that, we would have our suction port on the right and our discharge port on the left. All right, so we're looking dead down on the barrel. All right, so every single time we come around, we're going to be sucking in on this entire side over here. And as soon as we reach this point, we're going to start discharging all of that fluid. Now, if we do the reverse, it flips it. We now have a discharge port on the right and a suction port on the left. And of course, if we go to the neutral position, there's a zero stroke. We have basically a no flow. All right. Any questions on that? Because we're just about to build on that in a few seconds.
What's the component that changes the tilt, like that little spring looking symbol?
What is that?
Yeah.
It's just basically that's just the component that's used in that instance that's going to be changing it.
Okay.
All right. We don't use that piece. We're going to the next slideshow is going to show basically what we use to do that. All right, it would definitely be using either some sort of a spring or hydraulics to change the tilt plate, because you're not going to want that. No, I did not want to do that. Hold on. You're not going to want something where you have your tilt plate, and if you had a piston that was sitting up here, and of course it had a spring on it, you don't want something that's going to be pushing on this tilt plate to be able to flutter back and forth with any vibration. And that's what that spring would basically be doing. And you would have something that would be like, that would move this piston back and forth or what have you, or that was supposed to be an eraser, or something you can have is, if this is your tilt plate again, you could have something along the lines of another piece of hydraulic where you would have a small piston that sticks out. And again, it's going to be hydraulically locked into that position. All right. Basically what it's trying to do is keep that tilt plate from just vibrating or going and changing the direction.
Okay.
Okay. Anything else before we move forward? All right. Alrighty then. Also, has Aaron joined us yet? No, I guess not. All right. So let's talk about steering gear systems. So some component names. We have our rudder. All right. From there, we go up into our rudder stock. And from that is to our tiller. Now, we have our steering gear pumps. We have something called the 6-way valve. And we have our rams. All right. Those are the major components of our steering gear system. So again, we have our rudder. That's our dotted line right down there. We have our tiller, and we have our rudder stock. All right, we're just looking straight down on it right now. And of course, we have our rams. So if we want to move the rudder to starboard, all right, we're going to take these rams and we're going to force them in opposite directions. All right. So turning it to starboard, as we force them in opposite directions, one's going that way, one's going the other way. The tiller basically has to ride on those. And that riding on those plates are called the Rapson slide. All right. Now, they are not physically bolted together. There are no bolts through bolting here. Okay. If you notice, we now have room in between. These are basically, these cubes are attached to the rams, but they are just basically riding on that tiller, and vice versa. These rams won't move far enough that these cubes on these rams are going to fall out. All right. They will travel far on it, but it's not going to be something where you're going to have to be worried about this falling apart. All right. But just know that they're not attached to each other, but they ride on each other. So in order to move the rams, we're going to use one of those axial piston pumps. All right. So if we look at that, we have the ability to, on one side, we come over. This side, A and B and B are going to be physically attached to each other. All right. A on our forward ram and A on our aft ram are both going to be doing the same thing. If A is pushing, then both sides are going to be pushing. If B is sucking, then both sides of B are going to be sucking. All right. So right now we're in an off stroke, or we're in a neutral stroke position. We have no movement on our rams. All right. But once we go into a starboard discharge, both sides of A have done the same thing, and both sides of B have done the same thing. All right. A has pushed while B has sucked out. All right. And now our rudder would be pushing and showing in that direction. All right. So, does it take all that time to do that? We have on A again, has done the same thing on A on this side. All right. Remember, they're going to be opposing in different directions. So let's talk about pumping action and ram movement. Like we talked about, one side becomes the discharge and one side's the suction. We are going to have movement on our ram. All right. And as soon as that tilt plate goes in the opposite direction, we now have the reverse of what we just had. The side that was suction is now discharging, and vice versa. And that's how we move our rams one way or the other. Let's come back to center. Now, one thing I want to make perfectly clear. We're going to be talking about both axial piston pumps. All right. That's our representation of axial piston pumps. We're going to be calling this one starboard and this one port. The reason we call them starboard and port is because one is on the starboard side of the vessel and one is on the port side. You might as well call them 1 and 2, or A and B, or pound signed and explanation point. It doesn't matter what you call them. The biggest thing I want to get a point across to you guys is that the starboard pump does not handle starboard rudder movement only. Just how the port pump doesn't handle port rudder movement only. They both are axial piston pumps. They both can pump in either direction. and they both can handle moving the rudder from starboard to port and port to starboard. All right. Calling them starboard and port pumps are just their names because of the location of them on the vessel. All right. They do not handle their respective direction just because of their names. And that's what I was saying. You can call them whatever you want because they will do any work. All right, does that make sense to everyone? Okay, cool. So let's talk about the six-way valve. All right. So the port pump is going to be on standby, and that standby can mean two things. All right. It's either secured, which means it's off, or it's running, but it's going to have no fluid flow. All right. Take a look at what we have here. Let's call this our suction, and this our discharge. And if we, same thing here, suction and discharge. If this port pump is secured, we're going to have nothing flowing anyway. It's off. Doesn't matter. But in some cases of vessels, you will see the standby pump running. All right. It's just going to be sucking in fluid this way and discharging fluid this way. And it's going to be going into this six-way valve, comes back out of the six-way valve, and goes back into the pump. That's all it's going to be doing the entire time it runs because it's in the standby position. Meanwhile, our starboard pump is the one that's actually going to be moving fluid and moving the vessel and moving the rams because of what's happening inside of our six-way valve. So the reason we have this six-way valve is because we're going to be using a common stroke mechanism. Some component, as we'll talk about later, will move both of these tilt boxes at the same time. All right. Does that mean that they're both going to be influencing these rams? No, that's because of our six-way valve. All right. Let me erase everything so that way it doesn't become confusing. All right. So what we have here. We have our discharge going down. We have rams moving. Meanwhile, our port pump, our tilt box is moving, but we have just circulation of fluid. Okay? Now, if we go in the opposite direction with our tilt boxes, the opposite happens. All right? We're going to have a reverse fluid flow. Our port pump is still just going to be recirculating. It's just going to be recirculating in the opposite direction. And our starboard pump is still going to be influencing which direction our rams are going to be going and which direction our rudder is going to be facing. All right. Remember, just because it's called starboard and port doesn't mean that the starboard pump can only point the rudder to starboard, and it's the port's job to bring it back to port. All right. They can do either. So, as always, with anything on a vessel, the reason we have two is backup. All right. Just because one of these things can do both jobs doesn't mean we shouldn't have another in case something breaks. All right. Steering and propulsion is something you don't want to mess with. So how do we switch? Well, we switch it using the six-way valve. All right. So position 1 was the starboard pump online. Position 2 is the port pump online. And we'll talk about position 3 in the next slide. All right. So starboard pump is on standby. Port pump is going to be influencing these rams. All right, again, still the same common stroke. As we can see, the port pump is going to be moving the rams just as the starboard pump was doing earlier. But now the starboard pump is going to be just circulating fluid in and out of the six-way valve. Whereas the port pump is going into the rams, back out of the rams, and back into the pump. All right. And again, it could do either direction. I cannot say that enough. If these pumps were in line with each other, where you had one pump here and one pump here, you would just call them the forward and the aft pump. All right. Remember, these pumps are just named because of their position on the vessel. So the six-way valve has 3 positions only, not 6. It's called a six-way valve because they has 1, 2, 3, 4, 5, 6. All right, 6 inlets / 6 outlets, depending on which way the fluids are going to be going. All right. So position 1 is starboard pump is online, port pump is on standby. Position 2 is port pump is online, starboard pump is on standby. The third position is a rudder locked position. All right. You would only use this if you were doing, basically if you were doing work in dry dock, all right, where you didn't want the rams to be moving because you were doing work on the steering gear system. You know, if you were going to be called dead sticking, which is you have no power on the vessel and it's going to be moving from from one port to another position in the port. And basically you're going to be using like tugboats to move it around. So you'd want the rams to be locked on center. So you do this. All right. So basically position 1, position 2, normal operation. Position 3 is pretty much maintenance. All right. That's how you can kind of think about it. All right. But as you can see, any of the inlets are coming in. It just goes through, comes back out, and goes right back to the pump. And again, same on the other one. This is not going to be moving anything, and your rams are just going to be locked. Okay? Again, 6-way valve, 3 positions it can be in. It's called a 6-way valve because it has 6 ports coming into it. All right. Any questions? All right. Now let's talk about negative feedback. All right. So Basically, what's happening here is a thought process that you do daily. All right, when you're um, when you're counting something, if you're grabbing a certain amount of screws, all right, if you're picking up, you know, any sort of apples or anything like in the food store, you're going to be using a command, and that command is, the what you want. If you're going to be making like a pie, and that pie calls for 10 apples, that's your command. All right. And every single time it goes into the process and comes back out, and your process is grabbing an apple off of the food store shelf and putting it into your cart, that's your process. What you're going to be doing is your error is your command minus your feedback. So if your process is grabbing one apple, let's do this. Your command is going to be 10 apples. Your process is one apple, and it's going to be minus your feedback. Your feedback is how many you have at that point after you complete your process. All right. So your process is grabbing one apple at that point. You now have your command, which is what you ultimately want. Your feedback is what is out on your output on the opposite side of your output. All right. So if your command is 10 apples, your first time going into it, you have picked up one apple. And you start back up, go into your feedback, your error is going to be 9 apples. So instead of what's inputting into the process of being 10 apples, you have only 9 going into the process. But your process still is only going to allow you to grab one apple at a time. So the next time you come through, you have 2 apples. All right. So, but you still have a command, an ultimate command of 10 for the recipe. So instead of an error of 9, you go to an error of 8. And you keep repeating that until you are met with the condition of what you want. Your feedback is equal to your command. All right. Does that analogy make sense to you guys? Okay, good. That's all what's happening here. All right. That's all what's going on with any of our, when we move into the next step of what's happening is our differential gear. Okay. So we have input gear number 1. We have input gear number 2. We have our output gears. We have something called a yoke. All right. And this movement is going to be the same thing as our negative feedback command. All right. So on input gear number 1 is going to be our helm input. All right. Input gear number 2 is coming from our rudder. Now, why would we want that? Why wouldn't we only care about what our helm says and not why are we going to care about what's going on with our rudder? All right. Why don't you guys think about that while we go on break? So we'll meet back up at 10:15. All right. Why do we need two inputs going into one output? And why is one of them our rudder? Shouldn't we only care about what our helm is? All right. So see you guys at 10:15. All right. Everyone back? We're missing one person still. Perfect. So let's go through. As we're talking about, we had, two input gears here. Why would we want to have a rudder input? Whereas we should only care about what our helm is saying. Why does it matter what our rudder is doing? Anybody have an idea of why we need the input of the rudder for our steering gear system? All right, to take information about the rudder's location. Yeah, so we want to know what it's doing so that way we can have that negative feedback loop. All right, because if we can't see, we have no input of what the rudder is doing, how are we going to know when the rudder ends up where it should be or how much farther it needs to go? Okay, that's the whole point of having two input gears. Yes, the input gear of your helm, but the other input gear is going to be what your rudder is physically doing at that point. So let's look at what's actually happening in this differential. All right. If we look, we have one gear here, we have another gear here, and then we have two gears that are our outputs. So what we're going to be seeing here is that our input gear is going to be coming in. They can rotate on their axis. All right. But what's going to happen is our yoke and our output gears are going to be able to swivel while also rotating on their axis. All right. So if we look at that, that's what I mean by they're actually going to be rotating. So that yoke is going to move, and those output gears are going to move, even though those input gears are going to stay stationary in their physical location, but they're going to still be rotating. All right. So what's happening here is that this input gear is going to rotate. And as it spins, and as that input gear spins on its axis, it's going to try and move whatever it's in contact with because it's geared. And as it rotates on its axis, it's going to try and push on that output gear, both on the top one and on the bottom one. And since both of those are locked onto this yoke, they cannot spin, but what they can do is they can change their direction, where their position is. And that change of position is going to allow that force to be pushed out. New gears are going to go into the gearing, and it's going to just rotate because of that effect. All right, so if we watch this animation, this is our output gear right here. This is another output gear. All right, this is a gear that's coming direct from our rudder, and we have the blue and the yellow. All right, blue is going to be from our helm. And these are the blue arrows. All right. The yellow arrow, that is from our rudder. So this is input 1, this is input 2. right? This red arrow is just what we have right here. The rudder's going to be turning in one direction. We want to flip it to the opposite direction. Okay? That's what's happening with that red arrow over there. So as we watch this, we take a look at this blue arrow. That's what our helm is coming in. That is what we want. So what we want is going to be moving our yoke. All right? And once the rudder starts to move, we're getting input coming back from the rudder. And it's going and it's rotating the yoke back to center as it gets closer and closer to where it's going to be at the end result. Okay? Let's watch that again. So as it rotates, it's rotating our outlets. All right, that's what we want. What we have is coming in as well. It meets up and it comes back to center. So it's now in an off stroke position. All right. What does it mean to be in an off stroke position? Well, the tilt box that we are controlling with this yoke is now going to be an off stroke. All right. That's the whole point of this yoke right here, is going to be controlling our tilt box. So any questions about that whole aspect that I just went over? All right. So if we go in the opposite direction, it's going to go and it's going to move the yoke in the opposite direction. And thus it's going to move our tilt box into a negative tilt or a positive tilt, depending. Okay? Does everybody understand the differential gears before I move forward? Does anybody want it re-explained? All right. So going forward, this symbol right there is going to be our differential gear. All right. So what turns the input gear? What's going to be doing that input gear number 1 from the helm? What is happening there? Well, we have something called the rack. All right. So as the rack position changes, you're going to have basically a little gear sitting on this rack. And this rack is going to have basically a gear turned out on its one side. It moves laterally instead of in an axis rotation, and it's going to spin a gear, and that's gear is input number 1. Okay? So our rack is input number 1. Our rudder position is input number 2. Our output is X1, or our input number 1. So it's rack minus rudder. All right. So what moves the rack is a question you might be asking yourself. I know it keeps you up at night. It keeps me up at night. So we basically have a rack piston. All right. So this rack piston is going to ride in its own cylinder, and one way or the other is going to determine if you want a starboard or port rudder. All right. Same thing as what we have with our axial piston pumps. This pilot pump is going to be constantly running. When you turn on the steering gear system, this turns on and stays on until the moment you hit port and you go, hey, secure steering, we're done. All right. All the way across the Atlantic, when you're shipping cargo, that thing's going to be on. All right. Through storms, through a constant helm position, you're going to stay on whatever course for the next 2 weeks. If you're going from, the hell's it called? The Gulf all the way around the Horn of Africa, that's a pretty damn straight line. That thing's going to be on. Doesn't matter what's going to happen. All right. So we can change which way the fluid's going to flow because this isn't an axial piston pump. We're going to be using a shuttle valve. All right. So whereas in one direction where we are right now, we're going to not change the position of the rack. All right. Because of the flow, it's just going to be looping around. But if we go, come on, to that position, now our flow is going straight through it. We change the position of the rack. We suck out of one side and we push fluid into the other. And vice versa will happen when we change to the opposite. All right. So then what moves the shuttle valve? And these are solenoids. All right. They're electromagnets. Now, these are solenoids that are in a basically their state is normally open. All right. So in their de-energized state, they are not pulling in anything. But as soon as they energize, they're going to pull in that piece of steel or that magnet, depending on what they're using. All right. So when they energize, they push or pull, depending. This one's going to pull in, and it's going to move the shuttle valve. All right. And vice versa. If you go onto this side and turn on your solenoid, it's going to pull all the way to this side. And when they're both de-energized, you have your middle U joint that's going to be circulating your fluid through the pump. All right. So as the other one energizes, everything's all happy. And when it de-energizes on both sides, it goes through the center. All right. Now, how are these solenoids energized? Basically, when you turn the helm to port, it generates a positive voltage. All right. This may be true on all vessels. It may not, but on our vessel, this is how it's programmed. Okay. Just know if it's going to be one way, it will be the opposite in the other direction. All right. So when we turn the helm to port, it generates a positive voltage. So the voltage that we produce is proportional to the turn. What does that mean? The bigger the turn, the bigger the voltage. All right. So as we get smaller and smaller and smaller, we get a smaller and smaller voltage. Same thing when we go to starboard, but just in the opposite direction. When we go to starboard, it generates a negative voltage, and that is also proportional. So that proportion is going to be transmitted into how much that rack moves. All right. A bigger turn is more movement of the rack in that direction, and vice versa. So with this rack, what does this little red line mean right here? What does that mean? All right, Ellie's saying it's the 0 point. That's correct. So basically, that is where our rudder will be at center line. All right, we don't have a port or starboard rudder at all. The actual rudder wants to be at 0. Okay. again, since it's proportional to the amount of movement of the helm, the more movement we have with the helm, which means we want a bigger turn, which means we're going to have a higher voltage or a bigger negative voltage, depending, we are going to have more movement on our rack. So basically what's going on here is a logic circuit. All right. What we have is we have our voltage of H and our voltage of R. So we have our voltage of the helm and our voltage of the R as inputs. And what we're going to be seeing is that the voltage of H minus the voltage of R plus what's going on our outlet. All right. So if we see it's a large voltage and a large voltage on one side, we're going to have some sort of a movement. All right. Basically what's happening in here is explained better on this slide than with all those numbers. What we have right here. All right. We have our helm position and our rack position. Again, going into some sort of a logic circuit. All right. Now the difference between those is going to be dependent. All right. So if the helm wants to go to port of the rack, we're going to have a positive difference, which means our shuttle valve is going to get sucked up into that direction. All right. So if the helm is starboard of the rack, the shuttle valve is going to be sucked in the opposite direction. So if the helm is equal to the rack position, then you have a zero position, which means neither solenoid is going to be active. All right. So what's happening here is the helm is being compared to the rack position. And that difference is what's going to be turning on one or the other. All right. Another one of those negative input. All right. So last but not least, let's actually just talk about the sequence of events here. Okay. So the steering gear pump is running in an off stroke scenario. All right. It means that it's running, but we have no fluid flow because it's in its neutral position. That tilt box has not moved because it is in its zero position. All right. The pilot pump is it's just running. All right. It's just recircling the fluid. Nothing is coming from the helm. We have no movement yet. The helm gives the order for a right rudder. The rudder, all right, still in that zero position at this point. The helm is just going to be moving. This is what we want to do at this moment. All right. The starboard solenoid energizes, and the shuttle valve directs the pilot pump discharge to the rack position. So that solenoid energizes. The rack moves because the pilot pump is going to be moving fluid now to that piston, and it moves the rack. All right. At this point, we're first time we're going to have movement in our steering gear system. All right. So the rack moves to starboard. Turning the differential gear now of input number one, it's going to move it until the rack movement matches the helm position. All right. That rack will have actual numbers on it that will correspond to the helm position. All right. You'll have 0 point, you have 10 degrees, 20, 30, and same in the opposite direction. So the rack moves until the helm position is what it's the same. So that rack, if we want 20 degrees on our helm, that rack is going to show 20 degrees. All right. Rack movement matches helm position. It de-energizes the solenoid and returning the shuttle valve to its neutral position. Remember that whole equation of what was going on. So what we have with the helm minus what's happening with the rack. If they're both equal to each other, then we're going to have a 0. And that solenoid is going to be de-energized. It's going to go to its neutral. All right, so let's kind of look at what we see on here. Number 1 of what we had on here is the steering gear is running on an off stroke. Pilot pump is just running continuously. The helm turns to starboard. The shuttle valve moves. We now have fluid flow. This is the first time we're actually going to have movement down there. That helm actually matches the rack. All right. Once that happens, this shuttle valve goes back to its neutral position. All right. And we have done our first input into the differential. So going from there, all of that has happened. We have not moved the rudder at all yet. All right. The differential gear outputs to the steering gear pump and it puts it on stroke. All right. That input number 1 has moved the yoke. That yoke has moved our tilt box. All right. Now, as soon as that tilt box slightly starts to move, we're going to have a suction and a discharge. All right. The rams are going to start to move because we are now going to have output because of our actual steering gear pump, our axial pump. All right. The rudder begins to move to starboard. The rudder's motion, now it starts to move. Just as soon as it moves that 0.0001 repeating whatever degree, you're going to now have input gear number 2 putting input into that differential. All right. The rudder motion is transmitted to the differential gear number 2. The differential gear output takes steering pump off stroke. So when they meet up, they're going to be rotating the opposite. And when they're meeting up and they're saying, hey, we have what you want. Remember that whole negative feedback? That's what's happening here. The yoke rotates back up and it goes to its neutral position, moving our steering box, our actual tilt plate back into its off stroke, and the rudder motion stops. And then everything is just going to restart the next time that helm moves. All right, so let's look at through the pictures. Remember where we left off? Input number 1 has just put an input into the differential. That differential has moved the yoke, and now we have moved our tilt box. Tilt box has moved. We're starting to output fluid, and we're sucking in fluid. Those rams will move to correspond to our movement of our tilt box. That rudder is now in position, and it's giving input back into the differential. It's spinning that yoke back into a neutral position. And it moves that tilt box back into its 0 stroke. And now we are ready for our next input. All right. Biggest thing here. All right. When you're in a no stroke scenario where this tilt box is in a 0 stroke and you're just looking, you hyper focus into that tilt box. Can you tell which direction the rudder is at that moment? And the answer to that is no. All right. This will give you no idea of where your rudder is at that singular moment. If that tilt box is in its 0 position, you have no idea where this rudder is. You just know it's not moving. All right. So if this rudder moves to starboard and it stops moving, that means that tilt plate has went to its 0 position. That's all that tilt plate is showing, is that it's done its job and it's locking that rudder into that position. If it's at its 0 stroke, it is happy where that rudder is. Okay? So, any questions on that? Nobody has any questions? Everyone feeling good about this? All right. So, quiz tomorrow. Quiz tomorrow on all what we did today, hydraulics 1 and 2. All right. Make sure you guys finish this strong. All right. You put in the effort here. You put it in all last semester. All right. You only have 2 weeks left. We only have the learning of what we're doing this week, and then we're going into test 3 and then the final. All right. This will make your life so much easier passing this class now. All right. Having to retake it again in the spring of next year is not going to be fun. All right. And like I've spoken about in classes before, you don't want to be in the lowest common denominator with maritime. All right. You want to be with, your class. And that doesn't mean like graduating with them or staying with them. I know plenty of people who graduated late. But what I mean by that is you don't want to be a special case. You don't want to be that one person who has like 10 C days short because of something weird that you just didn't do. Okay. And now you have to be running around and trying to figure out how to get those 10 C days because everyone else in your class has those 10 C days, but for some reason or another, you just couldn't get it. All right. You got sick on cruise or, you missed too many labs, but you still got to complete. Something weird happened. I've seen crazier things than that happen when I was at Maritime. Okay. So make sure you guys finish this strong. Okay. If you have questions, email me. I'll help you guys out. Okay. Remember, there is a tutor. Even though one of the times the tutor is telling you guys that he can meet is during the middle of the class. I don't know why they chose that, but there is a tutor. You guys all have gotten that email. All right. Because if you're not getting it how I'm saying it, then maybe the tutor will give it to you a different way and it will make sense to you then. All right. At the end of the day, the important thing is that you guys understand this, you build a good foundation. Okay. So that's pretty much it for the class. It's going to be hydraulics 1 and hydraulics 2. If you're looking on it on Blackboard, let me just double check here that it's all set. I don't want to send you off with the wrong thing.
There was only one up when I checked, and it was only up to 27 slides.
Okay. I will fix it literally as soon as we get off, all right?
Okay.
Yeah, no, I'll take care of this. It'll say hydraulics 1 and 2. Okay. That's refresh. I don't want to delete that. So yeah, I'll take care of that. All right. Anybody have any general questions? No? Okay. I will see you guys tomorrow. All right. Be ready for the quiz for tomorrow morning as well with this. All right. See you guys then.
Have a good one, Professor.
Have a good one.
I have a quick question.
Yeah.
Can you go over like when I took this class last semester, it kind of like I remember taking the test, the final test, and I got confused on some like the terms with like off stroke, on stroke, and neutral.
Okay.
Can you go over those?
All right. Let me 1 second. Pull this up for you. So let's talk about it. So we got on stroke. All right. On stroke is talking about the tilt box. All right. Where that black line right there is going to represent my tilt box. All right. And what we have is an on stroke is going to have a tilt box that's, come on, I click black man. That's actually going to be physically moving fluid.
So that's like just when it's on.
Mm-hmm.
Actually, just on.
In like in almost like an engine kind of scenario, you can think of it being on stroke. It's actually stroking up and down. All right.
Okay.
And that tilt plate or a tilt box is going to move. And it's going to actually physically move those pistons. All right. It's a really dramatic version of it, but remember, it's going to travel in this direction.
Right.
And this piston in position A is going to be in position B in a few seconds. But while it's moving this way, it's going to be sucking in that fluid. So it's going to be an on stroke. All right. So for an off stroke, or it could be set as a neutral.
So those are the same thing.
Yeah.
Because I remember like I asked my friend about it after the test, and he kind of confused me a little bit. But it was like I didn't know if off stroke, neutral stroke, or neutral position, and then like zero stroke were all the same thing or different.
Yeah, and then you even have zero stroke as well. All right. And that's why on the test, I believe I had something written in there where I believe I said it as in 2 ways, where I said it was the tilt plate was in zero stroke, and I said something along the lines of like IE was there was like a no fluid flow, or I said it was a neutral position, something along those lines. I explained it 2 different ways, so that way if anybody knew one word or another, they were able to do that or try and use it to figure it out.
Right.
Okay. Because I know I used 3 of these ways of saying it, but that's because you can hear it from almost 3 different throughout the PowerPoint. It changes. All right. So all of these can mean the same thing, and everything that you talk about with that pump is going to be referencing to that tilt box. All right. And then again, what we're seeing here is that it's going to be from piston A to piston B, those positions, it's going to still be rotating. And as it rotates, you're not going to have any movement of those pistons. So it's not going to be stroking along the x-axis here.
The pump's still on, it's just not rotating.
No, the pump is rotating and the pump is on, but the pistons are not moving laterally.
Because there's no tilt.
Because there's no tilt.
Okay.
All right, remember that tilt plate is going to be what's forcing it to ride.
Right.
All right. And, these pistons are going to be basically doing whatever that tilt plate tells it to do. And no matter what we talked about is that makes this pump so great is because it can be on constantly. So it's on always. All right. It can run in the same direction. It can change the fluid flow. And it can change the fluid flow without changing direction. All right. And it's done that because of this tilt plate right here. All right. So when it's an on stroke position, this tilt plate is going to be rotated either in the way it's shown in this picture or the way it's shown in green right here. All right. But we're still rotating. But now instead of A being the point where you start sucking, we would have position 1 would be the point where it's discharging. They would flip-flop because the plate has moved. All right. And that's an on stroke. All right. So an off stroke would be in a neutral position where this tilt plate is sitting neutral. It's in a 0 position. If you were to take a protractor here and start reading degrees, you would be able to get degrees out of that. But that would be your 0 position. Your neutral, your off stroke. Okay.
Okay.
But your on stroke is when you actually have movement. All right.
Yep.
Does that make sense?
Yep.
Are you getting how that it's always running? The pistons still move? Okay. Good. You know, I wish that you guys can go into 6-hole right now. There's a pump down there you can play with, and all of a sudden it all just comes together.
Right.
You know. You guys did get the screw this year with that, as it always says. Other than that, do you have any other questions? Are you good?
Yeah, I'm pretty good other than that.
Okay, good. That's what I like to hear. All right. Nothing more than have a good one. I'll fix the hydraulics, so that will be done.
Okay.
All right.